Hello. Okay, so on this section we will discuss implicit differentiation. For instance, they give you the equation 8 x squared minus 2x cubed y plus y squared equals 13. As you can see, this equation is not given explicitly for y. It's not solved for y. So, but yet the question is to find y prime, which is what you call also dy dx. So if we try to solve it for y, it's going to be a little bit difficult. So that's why we can find y prime by taking the derivative implicitly. So what is that? What does it mean? Basically means we go to the given equation, we're going to differentiate the equation with respect to x, both sides. Okay, so this d dx basically means the derivative with respect to x. So we're going to take the derivative with respect to x of the left side equals to the derivative with respect to x to the right side of the equation. So you apply d dx of the left side equals d dx of the right side. So, but then we know when you're taking the derivative operator is linear. Basically means you can, when you're taking the derivative of a sum or difference, it's going to be sum or difference of derivatives, which means we're going to take the derivative of every term. And but then, so what happened is that, so when you're taking the derivative of an x terms, you're going to use the regular power rule, the power rule of derivative. But when you're taking the derivative with respect to x of y square of y term, you're going to use the power rule followed by the chain rule. Okay. So these are the two things that you must consider when you're taking the derivative with respect to x of the equation. So for the first term, 8 is a constant, so we just apply, since this is x squared, its derivative with respect to x is just 2x. Second term, we have two different terms. We have 2x cubed and y. So we can think of this as a product of two functions. Okay, so that it means when you take the derivative of that, we're going to use the product rule. So the product rule says to take the derivative of the first times the second function, then plus the derivative of the first function times plus the first function times the derivative of the second function. So then this negative sign is distributed to both terms. So first we take the derivative of 2x cubed and then times y, and then plus we take the derivative of we keep 2x cubed and then we take the derivative with respect to x of y. Okay. So when you take the derivative with respect to x of y, it just becomes dy dx. And then when you take the derivative of 2x cubed with respect to x, then you get a 3x squared. And then you multiply by -2. Here you multiply also by -2. So you get this. And then 8 times 2 is 16. You get 16x. Now we go to the third term. Since you're taking the derivative with respect to x of y squared, so you're going to apply the power rule first of a derivative, which will give you 2y. And then a chain rule says to take the derivative of y. So you get a dy dx. On the other side, the derivative of a constant is 0. So now you can see here, from this equation, what we're looking for is to solve for dy dx. So dy dx appears in two places. So first, so we know, just to simplify notations, we know dy dx is the same thing as y prime, as we stated above here, y prime or dy dx. Okay, so if I replace dy dx by y prime, it's the same thing. So now I have y prime here and y prime there. So what I'm going to do is take terms that do not have y prime, move them on the other side. So what I'm going to do is subtract 16x and then add 6 6x squared y. So that would bring this 2 over here. Now on the left side, I have only y prime. I can factor out y prime to get y prime equals quantity negative 2x cubed plus 2y equals the right side. Because we're solving for y prime, we can divide both sides by negative 2x cubed plus 2y. And then we simplify. So we get the answer y prime equals negative 16x plus 6x squared y over negative 2x cubed plus 2y. So that is y prime that we're looking for. We found it implicitly, meaning we differentiated implicitly to get y prime. Thank you.